All right, let's dive in. Today, we're going to talk about one of the oldest, most foundational ways to write code. It's called procedural programming. Think of it as the art of giving a computer a perfect step-by-step recipe to get something done.
So, let's start with a big question. Computers are, incredibly powerful, but they're also super literal. They do exactly what you tell them to do, no more, no less. So, how do you bridge that gap? How do you take an idea in your head and turn it into a set of flawless instructions a machine can actually understand?
Well, it all comes down to communication. We can't just talk to a computer like we talk to each other, right? Our everyday language is just, it's too messy. It's too ambiguous. We need a special kind of language, something super structured that leaves zero room for error. And that's exactly what a programming language is. It's basically a deal we make with the machine. We agree on a very specific set of rules and symbols, and as long as we stick to those rules, the computer gets what we're trying to say perfectly. Okay, so there are a bunch of different ways, different philosophies, you could say, for writing these instructions. We call them paradigms. And today, we're focusing on one of the very first and maybe most intuitive ones. The best way to think about it? It's like writing a recipe for a cake. And that approach is called procedural programming. It's a style where you organize your code just like that recipe, a clear step-by-step sequence of actions. The whole entire focus is on the how, the specific things the computer needs to do in the right order to get the job done.
So if procedural programming is our recipe, what are the ingredients? What are the actual building blocks we use to write these instructions? Let's take a look under the hood and break it all down. And this recipe metaphor is just perfect, because just like a real recipe you'd find in a cookbook, a good procedure is built from just a few key components. So let's look at the core ingredients of our code recipe.
Okay, at the very bottom, the most basic level, we have what's called a statement. This is the absolute smallest instruction you can give. In our recipe, a statement is like a single line. Add 2 cups of flour, or preheat the oven to 350. Each one is a single, clear action.
And what's so important here is that a statement has to be completely 100% unambiguous. When the computer sees something like x equals 10, there's no confusion, no room for interpretation. It just knows, take the number 10 and store it in a spot named x. That's it. Simple, clear, and then it's on to the next step.
All right, now what happens when you start grouping these individual statements together? Well, you get a block. So if a single statement is add sugar, a block might be all the steps for making the frosting. Mixing the sugar, the butter, the vanilla, all those related steps bundled up into one logical unit.
And this is where things get really powerful. A procedure, which you'll also hear called a function or a subroutine, is a named reusable block of code. Think of it like a little mini recipe inside your main recipe. Maybe it's how to make caramel sauce. You write those instructions just once, and then anytime your main cake recipe needs some caramel, you just say, hey, run the make caramel sauce procedure. It's super efficient. It's all about not repeating yourself. But a great recipe isn't always just a straight list of steps, A, then B, then C. Sometimes you need to make decisions, right? Or you need to repeat an action until it's perfect. This is where we need to control the flow of our program. And in procedural programming, we've got 3 main tools for controlling this flow. They are sequence, conditional, and iterative structures. Let's quickly go through each one.
First up is sequence. This is the default, the most basic one. It's just like reading a simple recipe from top to bottom. The computer starts at line 1 and just goes through each statement in order. No jumps, no loops, no surprises. Now this is where it gets interesting, because we can compare the other two. On the left, you've got conditional logic. This is all about making a choice. Think, if the cake looks golden brown, then take it out of the oven. Otherwise, leave it in for 5 more minutes. It's a one-time decision. On the right, we have iterative logic. This is all about repetition or loops. Think, while the batter is still lumpy, you keep stirring. You repeat that stirring action over and over again until a condition is met.
Okay, so we have our recipe book full of procedures and these cool control structures. But is this step-by-step approach always the best way to cook, so to speak? Let's talk about the pros and cons, when procedural programming really shines and when it doesn't.
So the advantages are pretty clear, right? It's simple. That top-down flow is really easy to follow, and using procedures means we can reuse our code. But as projects get bigger and more complex, it can get kind of messy. A big issue is that data is often just out there, exposed to the whole program. This means one function over here could accidentally mess up data that another function way over there is using. And that makes making changes really risky, because a tiny tweak in one spot can cause some really weird, unexpected bugs somewhere else entirely.
So let's zoom out a bit. What's the big picture here? What's the main takeaway for this whole procedural paradigm?
At the end of the day, procedural programming is all about giving your computer a clear, step-by-step recipe. You organize your code into these handy, reusable chunks called functions, and you use control structures to guide the flow of exactly what happens and when. And for any problem that you can break down into a nice, logical sequence of tasks, it is an incredibly powerful and efficient way to go.
And that kind of leaves us with one last thought. A detailed recipe is perfect for a self-contained job, like baking a single cake. But what happens when the problem gets way, way bigger? What if you're not just baking one cake, but you're trying to build and run an entire interactive city with millions of different parts all doing their own thing? Maybe, just maybe, a single step-by-step recipe isn't going to be enough.